In this lecture, we talk about interpolation search, which is an improvisation of the binary search. In the binary search, the given array is progressively divided into halves so that the key value is searched in the left part or right part. Now, sometimes what happens is if the key value is not towards the middle but it is towards one of the ends, then binary search will also take much longer time. So the question is how to identify whether the key value is located, where the key value is located. Towards this end, the concept of interpolation has been used here in the interpolation search, and this is more useful when the array consisting of integers or numerical values. In this case, what happens is it tries to locate the approximate location of the key and then reduces the subarrays into two parts so that the required search space is narrowed down or minimized. In mathematics, the concept of interpolation is used whenever the data values are available at two locations, and to identify or to know the data value at a given location in between them, what we do is we'll divide the given data range and in such a way that with respect to the a required value with respect to the ends of the intervals. So whenever x1, y1, x2, y2 are the two values, and if at x I want to know the value of y, then y can be computed in terms of the given data points, y1 plus x minus x1 by x2 minus x1 into y2 minus y1. So the given range is divided and the fraction of the location is identified with this formula. The same formula is being used here. If you look at the identification of the mid given key value, then we'll find the mid value. Mid is not exactly the middle, but the division point of the array. Where do we divide the array into subparts is important here. To identify the mid value where the array is divided is computed in terms of the formula x minus array of the low by array of high minus array of low multiplied with high minus low. What this formula tells us is the ratio between the required value x with respect to the array low by the total length or of total width of the array a of high minus a of low. This gives you the fraction of the subarray where it lies, and this fraction is multiplied with high minus low. The total high minus low is multiplied with this, which gives the fractional value of the subarray, length of the subarray, so that where the required value may lie. So this fraction x minus a of low by a of high minus a of low gives you some idea regarding the required value with respect to the total spread of the values in the array with respect to the high minus low. So once this mid is identified with this formula, we can divide the subarray into two parts consisting of array of low to mid and mid plus 1 to a of high. Now let us talk about an example here consisting of 8 elements 1, 3, 5, 6, 8, 10, 11 and 14, and the required key value is say 11. Then how do we divide this array into subarrays? So if I use that mid formula here, and if I can compute in the first instance, I can compute low is 0 plus required search value is 11 minus the starting a of low is 1. So a of x minus a of low, 11 minus 1 divided by a of high is 14, a of low is 1. So 14 minus 1 multiplied with high minus low, 7 minus 0. So when it is computed, it comes around 5.38, and since we take only the locations, so the integer value 5.38, 5. So the mid value is identified as 5. So that the key value is now matched with the a of mid, but a of 5 is 10 and the key value is 11, which is greater than that. So definitely the required key value lies to the right of this. So now we divide the array into two subarrays consisting of a of 6 and 7 as one subarray and a of 5, 0 to 5 as one subarray. And in this 0 to 5 subarray, definitely the required key value does not lie because it lies to the right of this. And Why? Because already the values are in the sequence sorted order. They are not in the zigzag form. They are in a sorted order. If they are not sorted in order, this formula will not work. Okay. So the basic requirement is the given array should be in a sorted order. Then again in the next iteration, we'll apply the same formula in the subarray consisting of two values 11 and 14. Again the same value can be applied, and mid value is found out to be 6. So a of 6 is incidentally coincides with the required value a of 11. So the algorithm stops here. This process can be, of course, whatever is the length of the array, once it is integer array or a numerical array, and the required value, the values are in a sorted order in an array, this method can be applied. Now we look into the algorithm, the process that we have seen in the case of an example. Just we can generalize this in the form of an algorithm here. We start with an array list, and n is size of the array, and k is the target value which is to be found. Initially we set the low as 0 and mid as -1, and high as, since the length is size is n, high as n-1. 0 to n-1 is the array size. Now in the while loop, while a key is not found or do not match, then we check the exit conditions also. Whenever the low is equal to high, that means only one element is there but key is not found. So that's a failure case. Only one element is there, key is not found. Or a of low is equal to a of high. That means the subarray consisting of only one element and key does not match. In this case also, we'll exit and the target is not found. That means target is not found and we're left with a subarray consisting of only one element. That is the scenario. This is the case, we'll exit, otherwise we'll continue and we'll find out the mid value. By using the formula that we have seen just now, we compute the mid value, and once we compute the mid value, directly we'll compare the a of mid with the key. Sometimes key may directly match with the mid, a of mid. If it is the case, then key is found, exit. If it is not the case, there are two possibilities. A of mid may be greater than k, or a of mid may be less than k. So if a of mid is greater than k, that's an indication that this k value may lie in the subarray to the right of this. So we set low as mid plus 1. Since at mid also the key is not found, so obviously it should lie between mid plus 1 to high. So low value is adjusted here, low is adjusted to mid plus 1. Or if k is less than a of mid, that means the key value is to the left of a of mid, that means the high value has to be adjusted. Low is again same as previous one, but high is adjusted in this case because the key value lies between the low and the mid to the left of mid. So we take high as mid minus 1, and the subarray now is concentrated either from mid plus 1 to high or low to mid minus 1, depending on the presence of k. Okay, so once this is identified, in any one of the cases are identified, the algorithm further proceeds again on the new subarray, and it progressively continues until either a case of failure occur or a case of value is identified. Yeah, when it comes to the best case, obviously when the array is in the sorted form and the key value is the first value itself, then what happens is we'll compute the mid value, and in the first comparison itself it coincides with the mid value, and that becomes the best case. And average case depends on the way in which the elements are distributed. This being a sorted array, if the elements are evenly distributed, then the average case may occur, and the worst case is obviously when the array is in the reverse order. Your requirement is to find out a key, but there is not in the ascending order. If it is, the array is in the descending order and your requirement is to find out a key, then obviously that becomes a worst case. More or less, the distribution of the elements dictates the way in which the algorithm behaves. If the values are unevenly distributed, then sometimes it quickly finds out the element, narrows down to the subarrays and quickly finds the elements. If they are evenly distributed, then average case may occur.